Let us discuss regarding timer. Prior to the introduction of programmable controllers in late 1960s, timing functions were implemented by the use of a variety of timers that included the spot, pneumatic and hydraulic, synchronous clock, motor-driven, capacitor time limit relay, electronic solid state, Horman 2013. Next, what are the types of timers? First one is on delay. When the timer coil is energized, there is a delay before the contact changes positions. The contacts remain in the changed position until the timer coil is de-energized, at which time the contact returns to the normal position immediately. This is the diagram for the on delay timer, where these are the switches, transistor 1 and transistor 2, which are the transistors. A, B are the 2 points, and 1, 2, 3 are the different bus. This is the symbol you put up for your normal open, time closed, and this is the symbol for normally closed and time open. It is represented by NOTC. Second one is NCTO. Next, off time delay. When the timer coil is energized, the contacts change position immediately and remain in the changed positions. When the timer coil is energized, there is a delay before the contacts return to the normal positions. Here also the timing diagram is shown here. This symbol for normally open, time open, NOTO, and this symbol is for normally closed, time closed, NCTC. Next, off delay. Interval 1 should. When the timer coil is energized, the contacts change immediately and remain in the activated position for the duration of the preset time period, after which they return to their normal positions. Retentive timer. If power is removed from the timer coil during its timing phase, it will retain the accumulated time, and when the power is restored to the coil, it will begin timing at the point that it stopped. Then recycle. When the timer is energized, the contacts change position at a rate determined by preset time. The symmetrical cycle, the on time and off time. The advantages of the timers. An advantages of a PLC is that the timing functions can be programmed, eliminating the needs of external timers. All timing functions can be duplicated on a PLC. Timers. The different definition of the PLC timers. They identify the timers and the location of the timer information. File type T4 allows followed by the timer number, which can be a value from 0 to 99. Next, time base. The duration of time base interval, that time is incremented in second, can be 0.1 or 0.01. So a value of 100 would equal 10 seconds with a time base of 0.1 or 1 second with time base of 0.01. Determine the amount of time that must pass to activate the down DN bit, expressed the unit of the time base. Next, accumulator. While the timer is in the timing mode, the accumulator increments in units of the time base. Enable bit. depend by En, true when the timer input is true. Next DON, down bit, depend by DN, true when the accumulated time equals the preset time. Timer timing bit, depend by TT, true while the accumulator is incrementing. Next TON, timer on delay. It counts the time-based intervals when the instruction is true. This is the instructional diagram. That is T on delay, timer T 4:1, time-based 0, preset 100, accumulator 0, En enable switch and Dn disable switch. Off timer, TOF timer or off delay. It counts the time-based intervals when the instruction is false. This is the instruction diagram. This one is time of delay, timer T 4:1, time-based 0:1, preset 100, accumulator 0, enable command, disable command. RTO, retentive timers. It counts the time-based interval when the instruction is true and retains the accumulated value when the instruction goes false or when power cycle occurs. This is the diagram for the retentive timers. This is retentive timer on, timer T 4:1, time-based 0:1, preset 100, accumulator 0. This is enable switch. This is disable switch. RTO retentive timers. It counts the time-based interval when the instruction is true and retains the accumulated value when the instruction goes false or when the power cycle occurs. That is so the retentive timer diagram. Retentive timer on, timer T 4:1, time-based 0:1, preset 100, accumulated 0. A few more timing functions. Other timing functions can be created using these timers in various combinations with each other and with other contacts. This is the contact for delay commands depend by the switch T 4:1, T on, timer on delay, timer T 4:1, time-based 0:1, preset 100, accumulator 0. See, this is the example for your timing functions. In this example, for each 1 second cycle, lamps 3 will be turned off for 0.7 seconds and on for 0.3 seconds. This one is the switch 2. This is delay command T on programming device, enable disable switch, that is GQ greater than or equal to source T 4:1, accumulator 0, source B 70007H. Is the lamp number 3. Other timing functions. The timer delay, timer T 4:1, time-based 0.1, preset 100, accumulator 0. This is T on, timer on delay, timer 4T 4:2, time-based 0.1, preset 100, accumulator 0. Other timing functions diagram is represented here. That is switch 2 and switch 2. Enable switch are marked here. Disable switch is marked here. This is time. The programming module is represented here. This is T on, timer on delay, timer T 4:1, time base 0.1, preset 100, accumulator 0, En, Dn 0 to 2/3, lamp number 3. This PLC timer provides a different options or precisions. One is a variety of options provided by the timer, reliable precision provided by the timer, flexibility for any applications.